We'll get started here in just a few minutes. But I thought there was something we ought to take care of to clean the business, the outstanding business. Some of you might be familiar, some years back, we were working on the SysML standards and stuff like that. And Jack Ring, who's one of our curmudgeons, that's a grumpy old guy, I guess is the way to put this, came, he says, you know, you guys ought to come out of the basement and take off your propeller hats. That's what he said to us. And now we could have taken that personally, but we took it as a positive thing that, right, we need to make ourselves more democratic and democratize this whole stuff. But we turned it into an award, and it's now quite the honor. I think it ranks up there with the Academy Awards for systems engineering. What we do is we put out kind of a call to see what kind of who's candidates. I mean, we work through the list, and we try to award at least 2 propeller hats every year. 2 years ago, it was 2021. We nominated Dr. Dov Jory to receive a propeller hat award, and we'd like you to come up here, Dov, please. He wasn't there. Just come up the stairs, please. He wasn't there to receive this award. I'm going to ask Troy to read the citation, if you can, Troy, because it's outstanding citation. We do a lot of work on the citations. So. And it turns out that Dr. Dory found out about via LinkedIn, didn't she?
Yeah, I mean, to be honest, I wasn't aware of the existence of this award before I got it.
It is getting popularity, that's for sure.
This is our idea is to award somebody that's helped us bring MBSE out of the basement. Make it widely available.
So for Dr. Doug Dory, for developing the object process methodology, for which he received the Technion Klein Research Award and several other awards. He's an IEEE Fellow, International Association for Pattern Recognition, IAPR Fellow, INCOSE Fellow. He's known for numerous INCOSE papers, presentations. Many of you have already probably seen some of those, even the training earlier this week. So thank you for all that you've done, and you're moving this forward, and that's what it's about. Getting up out of the basement. So here's your propeller hat, and you must wear it. You got to stick it down. Okay? So normally it's at the reception of the IW. It's normally at the reception of the IW. You start to see more and more propeller hats every year. People bring them back.
Bring back your propeller hat.
And they're there. So
thank you, Doug.
Thank you.
Thank you.
Well, let's go ahead and get started because we're on a tight schedule. Okay. All right, let's get started. Find a seat, strap in, because there's no time for any questions. We're going to move at 18-minute clips. That means that these presenters have spent a lot of time working on getting it packed into 18 minutes. Now, the reason we are doing this, of course, is we need to set some basics to make sure we're all on the same page. So I start with some fundamentals. Why systems engineering? You're looking at what was called the column of shame. In order to get into engineering school, I had to get admitted. And during orientation day, they took us down in the basement and they said, everyone will touch this column of shame because it represents the mistakes that were made early on, the architectural, and how you're not going to do these kinds of things anymore. And so we all touched it, and we made an oath to ourselves, like, you know, the Hippocratic oath, do no harm, if you will. And so the idea here is systems engineering, of course, in simple terms, is about engineering the combinations. The problems are no longer in the components. It's the combinations where the bad things happen. Today's products, of course, are combinations. I don't know of any products that are monodiscipline anymore. They don't exist, the combinations. And of course, model-based systems engineering is about scaling the systems engineering practice from document-based to model-based, because text does not scale. Okay? Models, of course, deliver and document this cross-product knowledge, and because it's the combinations where all these problems happen. So model-based systems engineering, of course, has to be integrated with the product lifecycle in order to deliver these cross-domain knowledge, and it needs to do now versus later, because there's no other discipline that even making no decision is a decision, right? So the idea here is we need to reach ourselves and work ourselves to what we call a continuous integration versus integration on the right side of the V. And we're starting to call this system lifecycle management. So the problem that you have is not complexity. The problem is that your systems, your products, your processes do not scale. And it produces a kind of an insane behavior on a lot of organizations where the same problems keep surfacing time after time. I'm a student of ancient Chinese lore, and I found it curious, the means that the Chinese, now it's year, I think 4,672 in China on the Chinese calendar. The way they tested for insanity is they handed the person they were going to test for insanity a bucket, and they pointed them at a pond. This pond had a little stream running into it. And they asked them as a test, empty this pond with that bucket. If they go and start emptying the pond without damming up the stream going into that pond, they are deemed to be insane. Okay. And so that insanity is carried on in many places all over the place. And currently you're spending 30 to 70% of your schedules and time working out the integration problems. Nobody ever denies that. Okay. And that's because we're having the problem of we're all living in silos, right? In fact, there's great quotes on the fact that this is the #1 problem in any organization you can come with. And we've gotten so used to it that we've actually become comfortable in living in these silos. My neighbor is building this one on the upper left-hand side. He's going to charge $300 a night, and you can live in a silo if you'd like for a night. It's a B&B, and he says he's booked up for 6 months out already because you're so comfortable in these silos. And of course, the reason you have these silos is your processes, right? You look here, the standard 4754 kind of process. There's silos everywhere. Silos of requirements, silos of tests, silos of manufacturing plans, verification. You get the idea. So when a requirement changes, it doesn't go anywhere unless you actually look through all the documents and stuff like that. And the result is there is no single source of truth. Any lessons learned, we have to go find them. It takes a lot of mining, and we're going to send half of our program schedules doing that job. We got to change this. Now, every MBSE initiative discussion or a meeting we ever have starts with this vision that we have. Now, you guys know about Vision 35, all the others. This one's been around for a long time. We just hold it out there and we start our meetings with this. And this is where I'll kick off the lightning round here. The idea here is the reason we have to transfer work to a document-based practice to a model-based practice is because this practice, this vision we're trying to achieve. Now, let's say, for example, we have a regulatory change that comes down about emergency braking distance. In your organizations, when you have a question like that, you form a meeting, you say configuration control board, do a trade studies, let's go get some people together, go find out where that goes, and you'll find out maybe months, years away of where that actually goes. But because we got this integrated MBSE capability, we can ask our car, this vehicle virtually, what's going on? And it can tell us the requirements for the front end of the vehicle and the braking distance. And so we ask it, what happens if we change it from this to that? 110 feet, 90 feet, they can come back and tell us these areas of the vehicle are potentially impacted by that change. And then we can drill into it. Here's a braking system, for example, with 7 different models reporting their perspective on the problem. You can see at the 12 o'clock, we got hydraulic fluid not compliant. Okay. We probably could have anticipated the thermal issues at 3 o'clock, but some of these are crazy. At the 5 o'clock, we see we've thrown a fault in our cruise control. And our mean time between failure calculators telling us we've got a problem at 3,000 hours. And for some reason, we've gone to 18 amps in our electrical circuit. So we drill into the electrical circuit. We find we've blown a fuse. We follow that to the schematics and to the harness. And we find out for the first time ever that we never realized we had this problem because when that sensor failed short, it caused this cascading effect, which would have resulted in a recall at 3,000 hours on a customer's driveway, hopefully. And now we got a new failure mode to keep up with, right? And of course, we can go reach out to our math model and fix our problem with our cruise control because it's generated out of a math model. And we might as well go look at the actuarial tables because we should be able to get a better insurance rate, right? Because we're stopping more faster. That's the kind of chain of events that we're after accomplishing with this integrated model-based systems engineering initiative. So today, we've been having a lot of time, spending lots of time communicating with you, with INCOSE members at the INCOSE MBSE workshops. Those of you who survived one of those fire hose experiences, or you're exhausted by the end of the 2 days. We decided we need to come with a way to pack more information into a shorter period of time. And we had this idea of a TED Talk. Okay. We couldn't use TED, so we're using Lightning instead. That's what it is. And so each of these speakers you see, Kyle Hall with Aerobase, Dr. Dory at Technion, Heidi from Mantech, Nicole Hutchison from Stevens, and Tom McDermott and Reagan Bolster are all going to talk to you, and they've been spending lots of time packing all their information into an 18-minute segment. We have a timer down here so they can see it in action, and we're going to cut them off at 18 minutes. So it takes a lot of time, a lot of effort to get all that information packed in. So that's why you say sit down, strap in. You can keep a track of your questions. We're going to try to have a Q&A at the end. Normally we would have a long conversation at the end, but given where we are in the schedule, it's hard to see whether we'll be able to accomplish it, but we'll try. So with that, we're going to introduce Kyle. you want to come up and take my place here? And then we'll start the timer on you.
Thank you very much,
Thank you.
Mark. So go ahead, start a timer. Let's get going. Thank you. So, hello, my name is Kyle Hall from Airbus. I'm a data-driven systems engineer, and today I'm going to ask you to please put an end to my MBSE frustration. So, for those of you who've read my abstract, it's a bit confusing because I start by saying that I've been a systems engineer for nearly 30 years. And you look at me and you may go, blimey, he's been doing this since a very early age. Unfortunately, the presenter who was going to be here, Jonathan Taylor, my colleague, couldn't come all the way to Hawaii. It's quite expensive to get from the UK to Hawaii. And I didn't want to take just his presentation and present it on his behalf. It didn't seem fair. He has a lot of experience in the field. What I wanted to do was come and talk about my personal frustrations. So apologies for those of you reading my abstract and then coming to see this. MBSE, in the opinion of we could probably share, is mandatory to understand the complexity of our products. We understand the need to utilize MBSE methodologies to encode the knowledge that we do into our product design. The current standardizations, however, for industrial maintenance of MBSE models is, in my opinion, and I hope you share it too, quite frustrating. Here's my biggest problem. I work for Airbus. We're a large OEM manufacturing products, and we're going to throw all of our knowledge, all of our understanding into different structures. We're going to have this full structured database of MBSE models interlinked and interconnected that define the future of our complex products. Fantastic. How do I archive that information so I don't lose that knowledge that I've just spent all my time and effort putting into one of these models? So let's go back to the start of human history and consider what we would possibly say was an ineffective way to archive knowledge. On here, you see some people, they're chasing after some animal, that's some kind of hunting ritual, and we cascaded that knowledge through the generations over the years through these cave paintings, and they've stood the test of time. So why don't we still do this? Why can't we paint an MBSE model on a cave? Seems to be a very effective way of keeping the knowledge going. I still can read this and understand what was going on, what was the definition behind why these people were doing what they're doing. It's a way of doing that. And then we get to, you know, the 90s, the 80s, and we're going to have all this paperwork, definitions of what we're doing. And we agree it's not an effective way to do it, but we'll file everything away. And we'll put it into a filing cabinet and we'll have all of our knowledge stored, and then it's there. We can go and get it back, re-pull it out, and we can understand it again. We can learn from what we did. So if we compare and contrast these two, we see on the left, we have what I would say is a diagrammatic way of representation of the knowledge. This is where we stand today with MBSE structures, a way of connecting human interaction into some kind of pictorial representation, something that actually has tangible value. We then add that and archive it still today, following the archaic practices of the past, following this way of filing into a filing cabinet somewhere, some storage server, our MBSE models. I ask you to consider how you would archive that data yourselves in your business. Do you have a special protocol in place for your MBSE models? Do you have that in following a standards-based approach that means you can re-access it in 5, 10, 15, 20 years time? If I'm defining a future aircraft program and I need to go in and check and revalidate why a decision was made, where do I get that data from? Well, it's great, because I filed it away in a PDF somewhere in some storage server. Well, what's the point of doing it in an MBSE model and not in documentation then? So in my opinion, I have this thing, we call it the Twitter pitch. It's a short little phrase of how you actually do these things. So who is interested in this? Who has issues? And I'm not going to ask for a show of hands because it may be embarrassing on my part if no one does. But I hope we all share this frustration that we do not have an effective way of archiving our knowledge today. What do we want? Well, we need to understand not just the knowledge and be able to re-encode it. So it needs to be something that technically is language agnostic, something that does not change, something that I can pull back in 5-10 years time, still understand, but I need to understand why I made the decisions behind it, the contextual understanding of what I was doing at the time and what the connections were there, not just the technical data held within my MBSE model. And why do I need to know that understanding? Because I can just have a bunch of data with no context behind it and it's completely meaningless. Case in point, I'm British, so I'm going to put a nice little red mailbox on here. How do you share your knowledge today? So great, we're going to use an MBSE model structure. We're going to save this in some proprietary format, or I'm going to email somebody a request or some data exchange. And in that email, there'll be some file attachment. Maybe it is some structural data that I put together. And I send that over in an email. I'll put in the text in the body, what I want you to do with that data. And I've identified you as the individual who's involved in that. So breaking down that sharing, that basic sharing of knowledge, I have a sender that is contextual metadata. Somebody sent that mail. There will be there'll be somebody who's receiving that, the two. There's a reason why that person received that data. There'll be some text in the field, in the actual body, that's explain what to do with that. You have to understand what to do with that. If that was in a language I didn't understand, then what do I do with that data? And actually, fundamentally, the attachment that's attached to the email that I'm sharing my knowledge to you with will have a file format, some code, so you know how to open it, what tool to use to open it. What if I sent you a mail that didn't have any of that? Just a data file attached to it. And this is the problem we face with long-term archiving, that in essence, if I do not have the full context behind why I archived some data, I don't know what to do with it. I can't pull it back out and re-understand and regain the knowledge that was lost or imparted into my knowledge management system. And going back to that, how do you recall your knowledge then in the future? So yes, it's in that system. I've got it all stored. What do you need to know? Do we know that the person who's going to recall that information knew about the organizational structure at that time? Do they follow the same ontological network and the way in which we impart that data today? So if you may have seen, I work for Airbus, we have the MOFLT architecture at Airbus. Do we know in 5, 10, 20 years time whether we will still understand MOFLT architecture? It's a valid question. Do we understand how we imparted that knowledge 20 years ago? And it goes back to those cave drawings. We can still understand those cave drawings. So fundamentally, we need to impart that knowledge in a domain neutral way that is language agnostic where possible, that follows machine interpretable concepts, that can make it understandable to the humans at the right time and at the right fidelity. So this is my shameless plug for those of you that were able to come along. I'm part of a community of people developing the MOSEC standard. MOSEC is a meta language. Now, there's a confusion when I say meta language. It's a metadata standard for recording context. It's not a meta model. It is a meta model, but it's a meta model of metadata, which gets very confusing. In essence, we record the context behind who's doing what, why they're doing it, and what are they doing this in. And we're working with other international standards partners to do this in a language agnostic way, so that I can inform a code within my system, a universal ISO recognized code that can only ever refer to one concept or component. That means in 20 years' time, that component will still be the same thing it was 20 years prior. And that's great. So we've recorded now, if you follow the MOSEC protocol, you have the context. Still doesn't tell you how to actually archive your data. This is where the LOTAR consortium comes in. We're part of the LOTAR consortium for long-term archiving and retrieval of technical data. It's not just MBSE, but I'm in the MBSE working group, so I'm going to push their agenda. What we do here is we define the standards and publish them publicly. You're more than welcome to join the community. We have these EN/NAS standards that we're putting out there now that allow you to see how to archive technical data, be it CAD geometries, electrical data, whatever you have, MBSE data, attached to it the headers that can be indexed and that you can recall and see and get the gaming understanding from. Then how you store your data, you have an index to that data file, and you can actually pull out in a language agnostic way, according to the standards I've just stated, how to get your data back and how to pull out that knowledge that already exists. Hopefully you stop people doing the same things twice. Hopefully you've indexed your system in such a way that if someone tries to redefine X and X has already been determined, we don't have to do it again. So I'm running quite early, and I planned that on purpose, because I knew we were kind of short for time. By all means, if anyone has any questions afterwards, please do seek me out. My email address is kyle.hall@airbus.com. Do reach out, and I hand over to the next speaker, please, to Professor Dory. I have 7 minutes. Thank you.
Does it work? Yeah.
Thank you.
Thank you. So can I use the extra 7 minutes? Okay, so the title is Model as a Cyber Physical System Driver from Deep Learning to Deep Understanding. So imagine that you're a systems engineer in a large electric motor manufacturing company, and the beginning at least is a true story. And you just receive an 8,000 plus page requirements documents from some world leading automotive producer for a new electric motor for the future 2030 and onward car. And your boss gives you 2.5 days to respond with, based on this document, the feasibility and the detailed conceptual model of the car. And you start scratching your propeller head, and you feed this huge requirement document in Agilon. And within 2 minutes, just over 2 minutes, you get a detailed model and a list of over 200 mismatching requirements, each with an argumented explanation. So is this science fiction? Currently, yes, but with Agilo, it will not be. So what is Agilo? Some of you may be familiar with AGI, which stands for Artificial General Intelligence, which is the holy grail of AI. It's defined as systems with intelligence that compares with and ultimately perhaps surpasses that of human beings. This was coined by Goertzel already almost 10 years ago. Now, we all know about large language models, also known as foundation models. And of course, the best known is GPT, with ChatGPT, which is a derivative that is very popular. These are deep neural networks with many billions of weights trained on large quantities of unlabeled text or images. When we say great quantities, we actually mean the entire intranet or whatever is on it. OPM, some of you may know, is also, it is an ISO 19450 and a model-based systems engineering and methodology. It's quite unique that it is both a language and a methodology. And Agilo is artificial general intelligence with LLM and OPM. Just on the right, what you see is a picture that I got within less than 1 minute by prompting this GenCraft deep learning software. I wanted it to draw for me an image of an agile, engineered, complex, socio-technical, and cyber-physical system. This is what I got. Quite nice. Just to give you an idea how great these things already are in terms of combining pictures and text, there is a system called DrillVL, which you give it a word like nature or time or science or dream, or even ideas like every cloud has a silver lining and so on. It gives you these wonderful pictures. I was stunned by this. And this is just in the last 6 months. Now, this is what I get when I ask them to draw large language models, fuse text and vision in marvelous ways. Again, this was drawn in less than a minute. I get several to choose from. So there is a new cohort of large language models just from this year about GPT-4. It performs strikingly close to human level performance, making it part of a new cohort of LLMs that exhibit more general intelligence than previous AI models. So these models exhibit exceptional and fast improving performance on a wide range of tasks, and they can be harnessed to carry out feats that were unfathomable a few years back. And really what is the limited factor here is our human imagination. So that's all sounds very good, but what does it have to do with model-based systems engineering? So the idea is that we can feed a foundation model with a huge systems requirement document, such as the one I presented earlier, and ask it to architect and design the system for us. Can we do this today? No. Why can't we do it? Primarily because LLMs lack explainability and interpretability. They have problems, they have an issue because they are based, as you know, on a statistical model that simply, at least for the text part, they are trained to put the next word given a previous vector of words, ordered words, they'll give you the best candidate to be put as the next word. That's how they work. But they have no idea why they did it. There is a slight difference, which I'm not going to spend time on, between explainability and interpretability. Interpretability is the more accurate term to be used here. The idea is that given some output of an LLM, it cannot, and we cannot, as humans, explain why this happened. And this is why quite often LLMs have hallucinations. They make up references. I experienced it firsthand. It took me a few minutes to understand that I'm looking for references that never existed. So explainable AI, or XAI, is required for reasoning about such tasks as assigning responsibility when an AI system makes a wrong decision that might be fatal, such as in autonomous driving, design of a new manned mission to Mars, or even medical and financial decisions that are detrimental. So I said there is a difference between these two concepts. We can skip it just to say that interpretability is the human's ability to understand and make sense of the predictions and decisions of large language models. And we all know that physicists, chemists, biologists are interested in identifying the hidden laws of nature. So only models that are explainable are useful in this domain. And of course, this is true also for engineers. They must not rely on systems that have that cannot explain or interpret their decisions. So our focus is to enhance the interpretability of the LLMs, what they output. Causality is to establishing the relations between cause and effect. It is closely related to interpretability, and it can explain relationships between variables and predict future events. This is, of course, a key concept in science, engineering, and many other domains such as philosophy, psychology, economics, and more. Causal models are necessary to explain causality. This is by Judah Pearl. So knowledge-intensive, cognitively demanding human activities, such as scientific research and engineering of complex systems, mandate that each step along the way be subject to humanly understandable logical argumentation. You don't want to come up with a system that said this was produced by LLM, but it's okay, don't worry, it will work, because it will sometime fail and nobody will know why, but you will be responsible for this. So it must be based on causality, common sense, first-hand experience of the real physical world. And turns out that OPM conceptual models are causal models. And therefore, they are especially adept at providing cause and effect-based explanations. They distinguish physical from informatical things. Things are objects and processes. They are bimodal. The visual diagrams, the graphical output, the object process diagrams are converted on the fly to sentences in natural language, which is called OPL, Object Process Language. They explicate what objects are required for each process as enablers or as inputs or as outputs, how object states change, what output objects result from each process. So processes transform objects. This is a universal tenet. And this way we can specify chains of events at any desired level of detail. We can zoom in, drill down, unfold, do a lot of things. So we start top down at a very abstract level, and we can go to any desired level of detail. Get all the way to minuscule hardware and software components from the entire organism, for example, to its organ cells and molecular interactions with them. And we have done this also for mRNA life cycle, for example. So Kyle here mentioned standardization. There is a currently under development ISO 17649, which I'm leading, which is model-based standards authoring. The idea is that the next generation of international standards will be model-based, meaning that instead of the text-based approach currently, in which we get requirements documents and international standards and any technical documents, in the spirit of model-based systems engineering, the underlying every standard and every requirement model, there will be a model. So, you know, put your money where your mouth is. This is the first model-based international standard is going to be 17649, which is the model-based standards authoring. This is how its system diagram, the top level diagram looks. There is a central main process here that is called model-based standards authoring. There is a model-based standard authoring team, which exhibits model-based standard authoring ability, and the conciseness level of the model-based standards through this process of model-based standard authoring is converted from free text to model-based and so on. So everything that I have been telling you and more is in the OPL on the right-hand side. So you can read and you see that these are sentences in English that make sense, and they are derived directly and correspond one-to-one to the construct, to the graphical construct on the left. For example, if we take line number 5 here, model-based standard exhibits conciseness level. Where does it come from? This is the, this comes from the, you see this little triangle, black and white, that connects model-based standard to conciseness level. This triangle is the exhibition characterization link, and that it is interpreted as model-based standard exhibits conciseness level. And the first sentence says conciseness level of model-based standard can be free text or model-based, which you can see in the left corner of the OPD, and so on and so forth. So every sentence here is an interpretation of some construct in the OPD. But arguably, the text on the right, even though every sentence makes sense and it is correct syntactically and semantically, it is easy to tell that it wasn't written by a human, but by a machine. In this case, the software OpClouds, which converts the diagram of every meaningful, semantically meaningful graphical edit to a sentence in English or many, like 12 other natural languages currently. So what I did using large language model, I took the text, which you saw, and asked an LLM, actually ChatGPT, which is based on GPT 3.5, to rephrase the OPL sentence into a humanly readable format. So here is what ChatGPT produced in the first try, just the first click, without, of course, it didn't have the colors that I put here, but everything else, this entire text was an interpretation of ChatGPT of what you saw in the text before. So I'm not going to read all of this, just the beginning. How am I doing on time? 4 minutes. Oh, okay, so I will not. So you can see that it makes a lot of sense, and everything here is based on the model. And going on, zooming into this, you get this, and with the text, and if I put this text, I get this interpretation, and this is like cast in concrete, because it's not just, you know, hand waving. Every sentence here is relying on some model fact that can be traced to the model. So LLMs and OPM complement each other perfectly. They are really like a match made in heaven. I don't have time to go through all the attributes, but you can see, for example, automation level of LLM is high and OPM is low, but the interpretability of LLM is low and OPM is high, and so on and so forth. So fusing them together really has a lot of synergistic potential. This is just the first picture from the Webb Space Telescope just over a year ago. Stunning pictures ever since. I am following it because I'm modeling the James Webb Space Telescope as a case in point for my book that I'm writing. Here is another one, more recent. So OPM is, like I said, is both a language and a methodology. It is based on a minimal universal ontology that says that you can model everything, every system at any level of complexity in any domain using two simple building blocks, objects as things that exist, and processes, things that transform objects by creating or consuming them or changing the state. It's domain agnostic. So Kyle, you were looking for something like this. It is easily understandable by humans and machines. It is an ISO standard, and the Agilo, as I said, is something that can be used to transform MBSE into the next generation, combining synergistically LLMs and OPM conceptual models. It's not just a pie in the sky. I have a detailed research and development program on how to do it. You don't have time to go through it, so you can just get some impression. 3 major stages: converting free natural language text into an OPM model. So the idea is to take a requirements model or a scientific paper, in fact, all the scientific papers in a particular domain and in all the domains, and once the LLM model is trained, to convert them into OPM models, which we are working on. I'll show you some examples. Then you can feed any technical document or standard or requirements document or scientific paper and get the OPM model of it. So you end up with a curated, evolving collection of knowledge base that is expressed as knowledge graphs that are converted from OPM models. They relate to each other. And this is just quickly how we are going to do it. We train it. And this is an example of something that we've already got. As source natural language sentence says, such stars are active, particularly when they are young, releasing ultraviolet and X-ray radiation that could destroy planetary. This was converted into the OPL sentence: young star exhibits infrared radiation, ultraviolet and X-ray, and this is the corresponding OPD. So we are going backwards, starting with the natural language to the OPL and from it to the OPD. More examples here. This is how we're going to develop the Agilo system. Again, same trick, generate the OPL, and on the right is the paraphrase, the natural language text that was done by an LLM. Okay, I think
Hello, my name is Heidi Davids, and I'm excited to tell you the status of the INCOSE Systems Engineering Laboratory, the SE Lab. Special thanks to Craig Ledger, Barkley Brown, Randall Sauterswat, John Nallen, Shatad Purowit, Mark Sampson, and also Steve Records for their assistance so far. So here's the vision for the SE Lab. What we would like for INCOSE members to have access to real full versions of SE tools for non-commercial purposes. And this is brought about by vendors donating access to both tools and computing spaces for and vendors in response also get exposure for their products and promotional consideration for their contributions. So here's the value proposition. What we would like for working groups to have access to contemporary tools, to be able to use those in their work and also to publish their technical products. Members gain exposure to a wider set of tools. Many environments, people only have access to a limited set of systems engineering tools, and we like them to be able to see a larger set of tools. In addition, we're trying to integrate this with other INCOSE services. So the Professional Development Portal, the PDP, there's training material in there. So people will have access to tools, access to training material about those tools, so they'll be able to increase their skill level. And vendors, they gain exposure to a broader audience. They gain exposure to more INCOSE members. And the purpose here is to accelerate MBSE adoption. So current status, since the IW this year, there's been much progress. We're looking for a full operational capability next IW at IW 2024, but there's some initial capability that's available now. So the initial infrastructure has been built. We're ready to enroll more vendors and more users. So we're hoping by IW 2024, we'll have more vendors that are willing to participate, more users that are enrolled. We'll have worked through some of the issues that we anticipate, and we'll have a robust product with a full marketing campaign behind it. So I'll talk about each of these 5 areas. First, the team and policy has been formed. The websites have been established. We have legal agreements, initial legal agreements in place. We've contacted vendors and enrolled an initial set of users. So if you're interested in this, we have initial capability that is ready to use. So for the team and policy formed, we have an SE Lab team that's established. We meet every other week. We do have a Teams area, we have Yammer area, and so we can collaborate in those mechanisms. We've also worked the integration with the Systems Engineering Tools database, SetDB, so that we can link from the lab to SetDB to make sure that we have complementary services. And just like with tech ops, technical operations, with service operations, we have a ServOps plan that governs new services as they're being developed. So the ServOps plan for the SE Lab has been written, it's been reviewed, and it's been formally approved. We also have a model of what we would like to have for the SE Lab. So there are a series of use cases that have been developed. We have requirements, we have some activity flows for how things will work with the SE Lab. These have been captured in the model, validated with the team. They're included in the ServOps plan and they've been approved by the services director. Now we anticipate there may be some iteration here and some disagreement, but this is what we have to work from at this time. So just to provide a little bit more detail, what we're hoping for is that each of the working groups will be able to collaborate in these tools to assist their working group projects. They'll be able to share models and they'll be able to distribute their content in models as well. And then individual members, of course, will be able to explore these new tools, explore tool integrations, and develop their skill in the tools. And for student members, this provides great access to be able to see some of the new tools. As they enter the workforce, they'll have already seen some of the latest tools that are available in the field. We're also hoping to link this to the mentoring service. So there's a new mentoring service available that's been rolled out here at the IS. So mentors, if you have expertise in a specific tool and you're passionate about sharing that with younger people, you can go in, sign up for the mentoring program, and in your profile, include that tool expertise. So we're hoping to link up some mentees and mentors to enhance the skill level. And then for vendors, if you're interested in sharing specific examples, sharing training content, you can contribute that to the PDP through this mechanism. And for INCOSE leadership, this can help with our integration between different INCOSE products. Okay, so these are initial websites that have been established. And once again, once we go through the formal marketing campaign, Marcom will scrub these and there'll be a lab icon and they'll be cleaned up. But this is initial capability that's available now. There's an external website that introduces the concept and encourages membership in INCOSE. And it's only INCOSE full members who can participate in the lab at this time. It's not CAB associates. That's an active decision that's been made. There's an internal website. So this provides the user agreement and also the map to the tools. And then each vendor who's participating has their own website. And from that website, they can provide tool access instructions, the points of contact, both an INCOSE point of contact and also a vendor point of contact, can link to the vendor sites and also link to SetDB. So we're trying to make sure that what we're providing is integrated with the other INCOSE services and products. So much of the spring was spent working some of the legal agreements. So there's a user agreement that's been approved by INCOSE Legal. And what it is a click-through user agreement for non-commercial use. We also have an initial vendor agreement that was approved that establishes the terms for vendor participation. And even since this slide had been submitted, there's an update to that general vendor agreement that's no longer in review. It's actually approved at this time that has updates for more open source and cloud-friendly wording. And in addition, there is a custom vendor agreement that can be worked. So one of these has been already approved through INCOSE Legal and the organization. So if a tool vendor would like to participate and they don't feel comfortable with the general terms, these customizations can be iterated with INCOSE Legal. Just let us know. Okay, so we did some initial vendor contacts. Like I was saying, the vendor agreements, the legal agreement took some time. It was just approved in June. And immediately after that, we talked to some of the vendors with initial interest. So this is actively changing. At this point in time, we have signed legal agreements with Dassault, with Inquiry, and OBO Soft. So we're very thankful for Dassault, Inquiry, and OBO Soft for their support of the lab. Archie and Capella are open source, open access tools. Those are listed in the lab in a separate area. And other vendors who have expressed interest are ANSYS, Intercax, Method Park, Siemens, Spec Innovations, Vitech, and also Lemon Tree. So any tool vendor may participate. There's just like the SetDB, there's no evaluation that's performed of the suitability or quality for any of the products. And so if you're a working group and you're interested in using the Dassault product, definitely come let us know. So here are some example users that were enrolled early version of the program. So the SE Lab itself, the SE Lab model was created and the content for the ServOps plan used the lab. In INCOSE services, we have an integration model where we're trying to integrate across the different INCOSE services. And that model is in the lab. SE Vision 2030 at 5 and Fuse. There are unofficial models of these for references and use by others. And just this week, the Fuse team, they've expressed interest in using the lab for some of the Fuse artifacts. So what we're really trying to get to is for INCOSE that when we publish a document, there are models that are behind it so that people can have machine readable artifacts that they can use in their organization and across their working group and initiatives. We also have a working group with who's interested in internal team collaboration using models. And another working group, they're doing some modeling and they would like to distribute these different modules and models to others across INCOSE. So that working group has been integrated into the lab, and we also have a professor who's just seeking tool familiarity. So call for participation. So as I said, this is a resource that's available to individual INCOSE members. So if you're interested in more information, let us know. The contact information is there. It's selableaders@incose.net. And if you're a vendor and you have a tool and you would like to participate, please do contact us. We know that several vendors, they just need to sign a legal agreement. We need to negotiate that legal agreement for their participation. And in the use cases that were defined, it's not guaranteed that each vendor will have all those use cases available for their specific tool. So there's some negotiation that may need to happen there. And also, if you think this is something that's of interest, we could definitely use help. So if you're interested in joining the team, please let us know. We're very interested in more momentum for this initiative. And if you have criticisms, questions, or suggestions, definitely let us know. The point here is that we're trying to accelerate the transformation to make systems engineering a more digital and model-based discipline. We think having access to tools can really help our membership move forward in that way. Okay.
Hey, thanks very much, Mark. I apparently am the only one who didn't get the memo about using the dark slides, so sorry about that. Sorry about. All right, so going back for just a second, you may have noticed I'm not David Long. David Long is here and he is my partner in crime in helping me think through some of this. And it's been quite a lot of fun to work with him. For those of you whom I haven't had the pleasure to meet, I'm Nicole Hutchison. I'm a principal investigator for the Systems Engineering Research Center. So one of the things that we're trying to do is help the Department of Defense navigate digital transformation, which is not an easy thing to do. So one thing we're trying to understand is what are some of the core challenges, and these are not specific to the department. They are also found in industry and a number of other places. So some of the folks who have already gone first, Kyle, Heidi, Dub, you've already touched on some of these. But I just want to iterate here some of the problems that we're all facing. So we have a lot of siloed data and information that makes it really hard for us to have this more holistic and integrated approach. A lot of people are still confused about what data really is and what it really means to have and control and manage data. A lot of organizations are having trouble figuring out what their strategy should be to enable this. Concerned about, but not sure how to predict or understand how it's going to impact their organizations. They have to deal with legacy systems. And from my research perspective, one of the most critical skills is this looming skill gap. So everyone wants to do digital engineering and model-based systems engineering. What does that actually mean? What are the skills that are required? So, you know, there are a lot of tools out there. We've heard about some already this morning. There are different languages. But figuring out the right way to move forward is just a roadblock for a lot of organizations. And so I think I've heard many things where we just picked a tool and moved on, and that can work, but you can also think through this a little bit more strategically. So what we're trying to do is come up with some way to make it easier for programs to deal with some of this complexity. And for some, that means that we're starting a brand new program. We're trying to stand it up digitally, but for a lot, it means we already have stuff going on. We already have some models existing, and we need to be better about making that a more integrated stream. So what we're trying to do is come up with a foundation, a set of archetypes that will make it a little bit easier eventually for the workforce to understand what's that scope and to really figure out where are the areas that they need to work on. So I'm going to talk about it from a program archetype perspective, but my end goal is to then carry that to the next step and help people understand how to better train and mentor their folks. Okay, so what we're trying to do is this. We want to understand the characteristics of a number of programs, and we'll talk about data in a minute. Collect data on that, and then analyze it to do a grounded theory approach and develop a set of archetypes. Now, what that means is there are going to be hundreds of variables, right? We could have all different profiles of what this looks like once we go through all the variables. But where we have a lot of mass, that's what we're going to call an archetype. So, you know, yes, there are probably 200 different profiles, but if there are 10 where there are a whole lot of mass, that's going to be useful for us because those are the areas where we can impact and affect the most people. Then we want to look across those archetypes and gather data specifically on their digital engineering implementation. So we're first going to categorize the programs, then we're going to look at them through interviews. I shouldn't use that word because there are so many IRB implications, but focused discussions for how they're actually implementing and using digital engineering tools, methods, and processes, and then developing a set of recommended approaches. And the goal at the end of the day is that if I know that this is the general type of program that I'm in, I've got some building blocks to start from. Now, this isn't going to be a perfect solution. The goal is to be at 70%. So if you're starting and you don't know where to start, and I can at least say, well, start here and then tailor and develop from there. The thought is that that'll be a ramp up for a lot of programs. So what is it that we're actually trying to understand about the programs? We live in the DoD space, so we included the type of acquisition. I'll talk in a second about what that means, and I will say that I'd like to have something that's not as US centric on that. So if you have thoughts about other ways to approach that aspect of the program, I'd love to hear it. Complexity and novelty, the technology, pace, scope, life cycle approach, et cetera. So these are the things we're going in expecting to find. Grounded theory says there's probably stuff we haven't considered that we need to consider here. And I would love to get your feedback on what are some things that we don't already have in our mental model that we should be adding. And again, we're looking to address what are their policies, processes, methods, the tools that they're using, are there common templates, common reference architectures, data sources, et cetera. Again, where we can provide guidance and access, I think that'll be very helpful. So in the US, again, Department of Defense, we have different types of acquisitions. So this is the Agile Acquisition Framework. What we're used to seeing, let's see if I can figure out how this works. This major capability acquisition is what we've been talking about in the DoD for a long time. If you've ever seen it, the giant wall chart that has like 70,000 blocks on it. And even when it's printed out on a 6-foot sheet of paper, you have to walk up to it to read everything. But there are a number of other things. The department's realizing that the way you manage those systems like F-35, that's not the same way that you need to do something if you're doing rapid prototyping. And that's not how you need to develop things if you have troops in the field who have an urgent operational need. So they're trying to formalize some of this. We've seen some of it in practice, but they're trying to make that clear. So one thing we want to understand, again, because we're funded by the Department of Defense, is how do those different types of acquisition approaches impact the way you need to do your digital engineering? Okay. But again, anyone, especially outside the US, is there an analog to this? So is there something else that we should be considering? I don't know the answer, but please come up and tell me, because I don't want this to be a framework that only works in the US. Then we haven't really done our jobs. So in terms of complexity, I think we've all seen the Kinevin framework. If you've seen any of Duncan Kemp's presentations, you've probably heard all about it. We want to look at complexity from a couple of different ways. So what you're seeing on the left is the Shinhar and DeVere Diamond project management model. And they talk about complexity I would say almost in a way that is more about how complicated it is. It's how many parts are there, and a little bit about the integration. So we want to take the information that they've already developed and also then say, well, okay, the Cynefin framework, how does that work? There are a number of dissertations right now going on about this. So I think it would be useful to sort of say, here's what we mean when we were talking about complexity, and just have a clear metric for that. So obviously the very, very simple programs, maybe you really don't need MBSE. I know that's heresy, but if what you're doing is very simple and something that you've done 1,000 times before, how much do you need to invest in this? We want to look at the life cycle approach people are using. I wish I know the V model is not everyone's favorite. I wish I could say that every program in the department is using the V model. So many of them are still using waterfall, which is a little disconcerting. But understanding how you're actually in your program approaching your life cycle. So waterfall, are we using a little bit more of a V, talking about integration and feedback loops? Maybe we're using spiral development. A lot of conversation right now is happening around DevSecOps. So what are the implications for the way that you're trying to approach your engineering process in terms of how you need to actually set up your digital environment and set up your expectations about how this will work? So what we hope to get to, and this is not real data, it's just notional, I want to make that very clear, is again, pulling the data from different programs and coming up with these profiles. And where we have center of mass is where we'd like to actually create what we're calling archetypes. I don't know what the threshold is. I would love to say, oh, if we don't have 50 programs, it's not an archetype, but I don't even know how many programs we're going to get data on at this point, so I can't tell you. But again, anywhere we have like decent center of mass, that's what we're going to call an archetype and go from there. Just understand how we're approaching that. And then the goal is to actually try and understand some common patterns across the archetypes, and then link that to what they're actually doing in their digital engineering. So their environment, ecosystem architecture, how are they managing data? What does their data governance structure look like? What data sources are they pulling in? What tools are they using? All of that good stuff. It's a lot of data in and of itself and a lot of work. But what we want to do is then have the linkage between the program profile and how they're approaching this. And what we're hoping to find is that there are some patterns. If you're a very large major acquisition program who's following, a traditional V model approach, and you're using, I hate to say Cameo because everyone's been saying that, if you're using Genesis, here are some things that you will commonly need to know and understand. So at the end of the day, we need the data to actually make this happen. The programmatic stuff is easier to get at. The thing where we're going to have a hard time is the access to programs to talk to them about what they're actually doing. So we want volunteers. If you have a program that you'd like to recommend we look at, or if you have a program that you would think would like to participate and let us come talk to you and understand what you're doing, we can talk NDAs and IRBs and all of that. But at the end of the day, I want you all to come help us understand this. If you think it's of value, then please help us get the data to support this. All right, so again, our end goal, we're going to develop these archetypes, and those archetypes will have kind of general patterns and profiles. Then we can say, all right, if this is where you're starting, here's your 70% solution. Make sure you're thinking about this in your environment. Here's the way you should be thinking about data. Here are some tools you should consider, some templates you can consider. Again, not trying to tell everybody this is the only way to do it, but at least give you the leg up and get started. That's what we're trying to do. And I just really liked this quote, and I hate reading off a slide, so I apologize for that. But true digital transformation is about having a digital strategy that enables innovation, and that should meet customers where they are while also meeting the demands of the future market. And part of what we're trying to do is that first piece of meeting people where they are to then help them prepare and strategize for the future. So with that, thank you very much. And I will pass them on.
Appreciate it. So we're going to tag team a little bit on this. I'm Tom McDermott. Kelly Alexander is my sponsor at Stevens Institute of Technology on these programs. She's with the Undersecretary of Defense Office for Research and Engineering, particularly the System Engineering and Architecture team. And I'm going to just preface this and turn it over to Kelly. Strategies to accelerate MBSE adoption and SE practices. The DoD digital engineering strategy was released just under 5 years ago. And it's been a catalyst for change, particularly in the defense contractor communities, but also in commercial industries and stuff like that. It unfortunately hasn't produced much change in the government itself yet. So very few government program offices are actually following and using the strategy and implementing the tools. So we're really concerned about adoption into the government. And so we started this project called System Engineering Modernization, which was, let's just take a look completely at how the government uses system engineering to acquire its products and develop systems. And maybe there's some things that need to be modernized to help the adoption. So with that, I will turn it over to you, Kelly.
Good afternoon, everyone. Good evening, I guess, for the folks that are on the East Coast that are potentially watching. Again, Tom introduced me, but our government sponsor, I'm actually contractor support to the Undersecretary of Defense for Research and Engineering. The government sponsors Ms. Nadine Geyer, who is not here today, but she provided the oversight for this project. So I like to talk about our journey, and this definitely is a journey. We do not have a final destination yet. We know where we need to go, but because digital engineering is still undergoing the transformation, and that underpins everything that we're doing, we realize that we're still on this journey. And so our story begins with a search for where the digital engineering transformation is within the systems engineering processes and technical management that's ongoing to support program development and program life cycle. And what we did was we focused on these areas that we knew that there was either congressional mandates that certain things happen, or that they were taking advantage of an opportunity to make things happen. And so digital engineering, of course, underpins everything that I'm going to talk about, but modular open systems approaches, mission engineering and agile software and DevSecOps were also part of our focus. And what we, as we developed the problem statement, because each of those were individually doing work, showing progress, but we saw a lack of an integrated approach to what was happening. And this lack of integration was delaying the full implementation of the digital transformation. And so as we began to go across the community with our collaborators, industry, academia, government, all of those groups participated in different workshops or opportunities to just share their experiences with us. And we began to see that there were certain areas that we could focus on: architecture, model-based systems engineering, of course, some of the enterprise collaboration and data that was required to drive the engine and help us understand and assess, and the engineering workflow that I talked about, the systems engineering tech reviews, the processes to manage and flow across the digital thread to enable your systems engineering decision-making, including your validation, verification, reliability. All of those have ongoing digital transformation activity. And of course, how do we get our workforce and culture to embrace what we're doing and to take that next leap into really realizing the digital transformation. So the only other chart that I'll talk about before I turn it over to Tom to kind of tell you what we found is that as we looked at where are we trying to go, what do we want to happen across the Department of Defense regarding a modernized approach to systems engineering. And we knew that shared data accessibility throughout the life cycle was really the key to that. And you'll hear more about that from Tom. Digital artifacts, I know everybody doesn't like that word, artifacts, but basically this notion that we're no longer a paper-based decision-making machine within DoD, that in fact we had digital artifacts with data that empowered them to help the community of stakeholders understand decisions and codify them as we go through the life cycle. That it would be model-based, that we would use models as much as possible to help decision makers understand interactions, interoperability, and the approaches, whether or not they were solid or viable, that they could make these trade-offs as early as possible. And of course, this notion of a digital collaborative environment, as yet not fully defined, but knowing that we needed to have the ability to collaborate in order to really realize a modern approach to systems engineering that embrace the principles and the goals of the digital transformation. So we developed these lines of effort that we thought were important to bringing the community together to help us start working toward the solution. I'll kind of focus on a couple of them because Tom's going to talk more about them. He's going to talk about the roadmap and the framework that CERT developed. Some of the work that DAU was doing, the Digital Acquisition Thread Exemplar, some of the workforce effort that's being done across DoD. We won't go into as much detail about that, but as he goes through the roadmap and framework, you can see how laying this pathway, our yellow brick road, if you will, to where we were trying to go, we were able to find out a lot of really good information, and some of the next steps that we're taking, we'll talk about that as well. So I'll turn it over to Tom.
Thank you, Kelly. So one of the things that we derived, and as we went in this process, you know, we had some grand goals. We thought we were going to be able to derive this integration framework by having students do text analytics on things, by interviewing people, by holding workshops, and all of that kind of stuff. And so we did do a lot of that, and we did talk to a lot of people. And, you know, what we found out of that process was the stovepipes and the silos are still really large, and they remain really large. And things like modular open systems approach don't integrate with Agile. They do really, but not in the way that we would call that modernized system engineering. So we ended up doing a lot of soul searching in this process across our team to kind of figure out what we really needed. And so we needed a better vision statement that was integrated. The DE strategy has got a great vision, but it's not necessarily a fully integrative vision. So that was one thing that came out of it, that the vision is to use data and models to create a more agile and responsive acquisition system that can quickly respond to needs. Nobody had ever stated that anywhere, but it's implied by everything, right? And so that sort of drove us. Then as we got into this, then we started thinking, well, maybe our mental models are a little bit wrong on how we do things. Maybe they're rooted in history and they're rooted in these silos and stuff like that. And so we ended up building this integration framework off of a couple of mental models. So the first one ended up getting drawn by Richard Wallace from Georgia Tech, who supported this. That it was so good in cartoon form that we could never change it out of its original cartoon form. And so if you think about what systems engineers do in their daily job, they probably have a bunch of data that they got to generate requirements off of, or they got a model. And so in a process that they go through, they integrate across many different engineering data sets and engineering data models. And then they probably do a trade study or a set of trade studies where they say, hey, the system's going to emerge into this level of performance or this level of capability. And so we're going to make decisions as we go through our review process based on these trades. And then we're probably going to get stakeholder buy-in on this eventual design. And you know, it's always been PowerPoint. As we started thinking about what these digital artifacts might be, they're still probably going to be PowerPoint at some point in time, right? But it's going to be PowerPoint that's augmented by a lot of data and models. And so this human process of using tools to understand the design and the development is always going to continue on. The bottom of that chart, the little diamonds, are data and model connectivity diagrams. So what's really happening out there is not that we need to build more models. It's not that we need to create new digital artifacts. We got to link the process together. We got to make that data flow up to the presentable artifact seamlessly and efficiently. So probably still have a graph. It's probably still embedded in a PowerPoint slide, but if the review comes up and they said somebody says, show me what it looks like if we change this variable, then I can change the variable and the PowerPoint slide will update. And we don't have to have an action item and come back in 2 weeks. We can do it in minutes. And that was kind of the vision. So one of the things I think then we realized is we're sort of getting our value equation. The value is not in more modeling or anything like that. The value is more seamless and efficient transfer of data and models from the underlying performance drivers through to the models, to the decisions, as well as ease of drilling back down the chain. And so, you know, one of the problems with this is when you start thinking about investment and return on investment, we were having trouble explaining the value statement. It's not buying an MBSE tool and doing that. It's making us more efficient. And if you're doing something in model-based system engineering, you're doing something in digital engineering, and it's not actually making you faster and more efficient in what you do, then you probably shouldn't be doing it. That's the kind of was our key message. And so that was a question. So it led to a bunch of recommendations really about how we start to manage digital engineering ecosystems over time and the process to do that. The second mental model that we came across was this circular model, which shows data as the core asset, because it's the fundamental asset of what we build things off of, transformed into models, and then transformed up to views, whatever artifacts that we have as digital artifacts, in order to analyze and make decisions. And then, you know, we realize that this is not something that happens once, right? It happens continuously forever and ever, as long as the system is actually in development and use. So the new system engineering lifecycle processes must evolve that address shared and authoritatively managed sets of digital data and models associated with the full lifecycle of the system itself, not just a single acquisition program lifecycle. And so, you know, we got to that point in time and saying, well, you know, should we retire the V diagram? Because we have this sort of history that has launched into us that it doesn't say you have to do it this way, but it sort of implies that the system lifecycle and the program lifecycle and the engineering lifecycle, they're all the same. They all sort of crunch together, and that maybe that's not quite the way that we look at it as we go forward. So that led us to this thing that we called the super system model. So we started looking at, hey, you know, the emergence is actually what the system experiences when you develop it and put it into operational use. So the system has its own life cycle, and it's going to learn things and it's going to trace things on as it goes through. The life cycle of the data and models you use, they're going to be associated with the system experience, not the program or anything else, right? So you have to think long-term, how are you going to maintain these things over the history of your program in some sort of data storage layer? You're going to have engineering life cycles. You'll probably have lots of engineering life cycles as you go through this process. And then you're going to have program life cycles. And so all these things have to come together, and they're all independent life cycles, at least somewhat. They may be aligning at points in time in order to make decisions. But then we said something's missing out of this. So then we had to go back to this guy named von Bertalanffy, who wrote this book in 1968 called General Systems Theory, and he named it for us, right? He called it the suprasystem model. That's the system that is the next layer up from the system that you're designing and building and using it. And so then we layer that on top of it. And we understand that most of our information, our useful information and data actually comes from the interaction of our envisioned systems and the use of our envisioned systems with their content. And we got to be capturing that stuff. And so, you know, there's not quite a place for this in the way we represent it today. So then we went back and we took that DAU wall chart. It's a very large linear thing. And we said, can we actually lay it on this circle and explain everything all at once and represent the real cyclic nature of modern systems engineering with the milestones that we have? And so we attempted to do this. This was called the super system model. One point in time, it was dubbed by onlookers as the bomb cyclone model. I think I called it once the toilet bowl model because it looks like the DAU wall chart is swirling around the toilet and captured a snapshot. But the idea here is that we've got to change our mental models to where we do things. So there's two times when your system touches the super system. One of those is over here in the operational test and initial operational use. So all the way in the top left corner of this system. There's another point in time when the virtual system touches this external context, and we're calling that mission engineering, concept development, all these sort of times. And so there's two components. One of those is the history of all the previous similar systems. And then there's the other one is my conceptual operational model of what the new system is going to look like. And if you actually look at how the DoD works, data never transfers across those boundaries. And in fact, the way the policies have been set up around mission engineering and all these other kind of things, we've just created bigger stovepipes in the process. So we're never going to do this. And so we're never going to get useful stuff if we don't take the previous history of our systems that we develop and give it to the contractors by the time we actually get a developmental contract in place, so that all the knowledge and data has been shared from what we want. And, you know, you probably saw pictures in some of the sessions today of this fact that the next fighter jet that the US develops is going to cost the whole DoD budget. There's actually a similar chart that shows the cost of automobiles has actually been going down as complexity increases. And so I don't think it's complexity driving this, right? It's lack of reuse. It's lack of reuse that is driving this exponential cost curve that we have. And so we're starting to see programs doing that. So what we're trying to do then is go back, and I'm not going to show it to you, although Kelly mentioned, we created a roadmap to help bring this circle all together. It's a roadmap of activities that span DoD acquisition and DoD engineering and workforce development in order to start bringing these things together. Obviously, the policies are all wrong right now. There's a lot of uptake. We don't have the ecosystems, but as Kelly showed, this is going to be a long-term project for the DoD. So as we go through this, we hope that we end up with this last slide, this continuous process where we start with our new mental model. We realize agility and the agile mindset is part of it. Then we start thinking about how we're going to build the models to become more efficient and agile. And then we're going to build all that and stuff it with all the data we have and create new data. And then we're going to create the ecosystems that allow us to collaborate. And so until we get that, we're not going to meet the vision. We're not going to meet the strategy, but you know, we hope that we're able to evolve this at least in the U.S. Department of Defense. And I know contractors are way farther along than their sponsors are in those domains, but we've got to all come together because it's a joint problem. And that was the last slide. Yep.
All right, so I make sure this works. So, hi, I'm Reagan Bollister. Want to thank you all for spending 6 long days in Hawaii just to see my presentation, the very last one. So this is proposing an MBSE minimum viable product for missions of all risk levels. So who am I? I'm Reagan Bollister. I'm a senior systems engineer at Lockheed Martin Space in Littleton, Colorado. I have degrees in mechanical engineering and systems engineering from the University of Michigan, go blue. And I work a number of what we call national security space missions. So unfortunately, a lot of these are classified, so I can't talk about the details, but what I can say is that I've worked on some large, exquisite, big money programs and some small, tighter budget, a little more freeform programs. And when I say satellites, I mean satellites that get launched into space. Sometimes I tell people I work on satellites and they think the DirecTV dish you hammer to your roof, which if you work on that, like no shame to you at all, that's just not me. And I like to say that I grew up with MBSE because I was working on MBSE even before I stepped into industry. So my master's thesis was on MBSE for flight software development under General Motors legend Harvey Bell, who I believe is an INCOSE member. And fun fact about me, I've hiked the Black Canyon of the Gunnison, which is the deepest and steepest canyon in North America. Not the Grand Canyon, as many people think. So what's up with the space industry? Now is a super exciting time to be in space. So historically, going all the way back to the Cold War, most government acquisitions for satellites have been these large and exquisite programs that were a lot of money, a little bit complicated at times, but things have been changing. And a really easy example of that is SpaceX Starlink program. So obviously, clusters of small satellites isn't the typical way of delivering internet to remote places, but it's working, and that's leading to a lot of new and exciting thought. Then the other big change is that in recent years, the government has gotten a lot more excited about MBSE, as some of the previous presenters have echoed. So in the past, used to be largely up to the contractor if MBSE was used in development, how much MBSE was used in development. But now I'm seeing both the company and government requiring the use of MBSE in development. And I've even seen a few programs personally where the government wants to be able to integrate their models with the contractors. So pretty big change and definitely an integration problem. So some really smart folks at the Aerospace Corporation anticipated the shift to different varied satellite programs all the way back in 1986. I know some folks from the Aerospace Corporation are here. So a little history on aerospace. They are a nonprofit organization that employs engineers and technologists, and they provide advice to government and military customers on their space acquisitions. So to give an analogy, imagine that you're buying a new car. I personally find this to be a very stressful experience. But imagine that you had the opportunity to bring an automotive expert with you to the car dealership to verify all of the engineering for that car before you buy it. So that's one of the purposes that the Aerospace Corporation serves for the government. So the Aerospace Corporation back in 1986 created this mission assurance guidelines. So this is a long list of standards for tons of functional areas, even some that aren't typically systems engineering. And it's basically a set of instructions for each of the mission classes, ranging from Class A to Class D. So these range in complexity, level of risk tolerance, size of budget. So Class A is considered the largest, lowest tolerance for risk, largest budget program. So examples of that are a GPS satellite or the Hubble Space Telescope, which I know inspired a lot of people in my industry to join. An example of a Class D mission is a University CubeSat demonstrator for NASA. So very big differences in the engineering between those two kinds of programs. And of course, Class B and C fall in the middle. Typically, the differentiator I see between Class A and Class B is the level of verification. And then the differentiator between Class C and Class D is the amount of government oversight and basically how much freedom the contractor gets in choosing how they want to run their processes. So Class C, kind of a combination of government-driven processes and then contractor-driven processes, and then D sometimes need a little bit freeform. So here's a line item of that mission assurance class guideline. This is the requirements development process. So something I would expect most people here to be familiar with. So the standard is the same between Class A and Class B because aerospace chooses to hold A and B to the same standard for requirements development. Then Class C, requirements development left up to the discretion of the contractor, and Class D simply suggests that requirements development should be done, but even gives the option to not do developments requirement. I'm sure the requirements working group is cringing very hard at that. But like I said, Class D can get a little bit freeform. So let's get into the meat of this a little bit. So as I've mentioned, government is looking to vary its satellite programs a little bit. we're not just going for these large and exquisite acquisitions anymore. Now it's a mix of smaller satellite programs and larger satellite programs. And the government is very excited about MBSE and is often requiring it on contracts. So I'm considered one of the MBSE subject matter experts within Lockheed Martin Space. People come up to me and say, hey, Reagan, I'm working this Class C or D program. I'm required to use MBSE. What does this mean? How much? And kind of had to say, there isn't really a standard for this. Just do what you think would be useful, which is not wrong, but I don't think is the greatest response. So that's led to me creating my own set of standards for MBSE minimum viable products aligned to each of these mission classes. So ultimately, this has been a passion project. I'm not doing this because of any manager or program. And a lot of it is kind of chalked up to my opinion, but I do think that I'm a good authority on this subject because I've worked a variety of these different program sizes. And I've chosen to align the standard to each of the different mission success criteria within the aerospace mission assurance guidance. So this is requirements analysis, integration, test and evaluation, design assurance, and software assurance. So I'll start off with some broad decisions that I made about this minimum viable product. So start off by saying it is a minimum viable product. It's not a list of everything that you absolutely have to do or should do. It is, this is what you should do at a bare minimum. And if you want to go beyond that, you can. And then I'm also going to say up front that what I'm presenting here today is a broad overview of what I've chosen for this standard. It would be incredibly boring if I spent 18 minutes just reading off a giant table, and I probably would get a very rotten tomato thrown at me. And one of the biggest decisions that I made was to break out Class C and Class D into two additional class types. So that is programs that have a lot of new hardware development and programs that are more software development heavy. So I've seen in my experience so far is that usually for these smaller programs, they have very big innovations in hardware or very big innovations in software. So to me, it made sense to treat the MBSE standards differently for those two types of programs. And I've also chosen to remain fairly tool agnostic when thinking about this standard. I think people get very excited about Cameo. You have to use Cameo, which is great. I love Cameo, but I think there's a lot of great tools out there and we shouldn't get too bogged down in the tools. It should be more about the processes. And even some of the tools like MATLAB that aren't traditionally systems engineering tools are useful for a lot of systems engineering processes. And then finally, I chose to follow a more additive approach. So for each of the mission classes, I thought about how would MBSE be most helpful and added process to the list. I think it can be really easy to fall into a pattern of thinking I shouldn't use MBSE and following a more subtractive process, which is unfortunately the viewpoint that I see a lot on these small Class C and D programs. We're really lean on people. We can't afford the time and the footwork to do MBSE. But I'm trying to think a bit more with the mindset of how can we lean on MBSE when we are so lean on people? So I'll start off with my high-level overview of each of these mission assurance areas, starting off with requirements analysis and validation. So Class A, pretty self-explanatory, should be doing as much requirements traceability as possible. And then step B is a slight step down, or sorry, Class B is a slight step down because typically the verification requirements are not as stringent for Class B. For Class C and D, I encourage the use of model-based requirements. There's already been some great talks on model-based requirements at IS, so I won't belabor this, but I will say that I think that model-based requirements are a really powerful tool for Class C and D programs doing a novel ConOps or architecture. And finally, I use the phrase extent that risk is mitigated quite a bit when talking about Class C and D. This essentially means that for that part of the standard, I'm leaving the extent to which MBSE should be done to the discretion of the engineer. So an example that I'll use for requirements is if you're working a Class C or D program that's leveraging a lot of high heritage commercial off-the-shelf hardware, It is up to the engineer whether they want to flow those requirements down to those off-the-shelf components or just treat them as a black box. Design assurance. So here I use the term classic diagrams. I know that's kind of a vague term, but that is by design. I at first was thinking, oh, this should be all the SysML diagrams. But as I said before, I've chosen to remain fairly tool agnostic. So this could be UML diagrams or even LML diagrams I just heard about this week. But any diagrams like internal block diagrams, activity diagrams, all of our favorites. And then for design assurance, according to the aerospace standards, Class A and Class B are treated the same. For Class C and D, we move into the territory of using MBSE to mitigate risk. So one of the key differences between Class C and Class D is typically development risk is sought to be mitigated in Class C, but for Class D, typically only safety risks are mitigated. And this again is by design. Class D could be a university project. It's higher tolerance for risk. As long as it's not hurting anyone, it's fine. But these are areas where I think sorry about that. So now peeking at the other side of the systems V. I know systems V, dirty word. For Class A and B, leverage internal block diagrams to model interfaces prior to integration. And then for Class B, verification requirements are a bit less stringent than Class A. So modeling and simulation may take the place of physical test for non-critical requirements. Moving into Class C, again, using internal block diagrams to mitigate risk. And modeling and analysis should be used to verify most requirements. So now moving into the final area, software assurance. So another area that I am passionate about is the use of software engineering tools for systems engineering practices. And I think software assurance is an area where CI/CD unit testing is really powerful for model-based systems engineering. So CI/CD unit testing is continuous integration, continuous deployment, which is a common DevSecOps practice. And these sorts of tools have high reuse and should be used on programs of all sizes. And I know Tom just hit on reuse, very important topic, saves a lot of time. And finally, software architecture should be modeled to, again, buy down risk. So that's all I have in terms of my high-level overview of this standard, but I think that there are some next steps I'd like to take with it. Again, this is a first draft of this MBSE minimum viable product standard, and I think there's a lot of potential here, and maybe some of y'all can help me with this. So I'd like to learn more about mission assurance in other industries and how they can leverage MBSE. So obviously the aerospace class system is inherently related to satellite design, but how does this same problem come up in the biomedical industry or automotive or power? I just don't know, but I think that could really contribute to this framework. And then I'd like to further develop the standard to include MBSE for functions that aren't inherently systems engineering. So the aerospace guidance contains guidelines for procurement, program management, all kinds of areas that I don't have experience in, but maybe MBSE could help. And finally, I'd like to further develop the standard to include more information for the second half of the systems V. I have most of my experience on the development side of the house. I'm not an experienced test engineer, but I think there's a lot of areas in which MBSE could be leveraged to help with integration, tests, and evaluation. So that's all I have today. Thank you for listening. Again, I'm really interested in continuing to iterate on this framework. So please feel free to reach out if you have any suggestions or want to roast me. And I hope that I've inspired you to think about how MBSE occurs in programs of different sizes in each of your industries.
Thanks. Raymond Wolfgang, Sandia Labs in Albuquerque, New Mexico. And Reagan, I had a question there about the A, B, C, and D, and I'm just wondering if in your future work, okay. If you're planning to, if there's a way to sort of have risk and size independent, we have some small projects that have high, let's say, schedule risk. We just don't have a lot of money. But I think MBSE might be the only way to actually hit, the scope, cost, of schedule. Is there a way to socialize MBSE for those types of projects?
Yeah, so just make sure that I understand correctly. You're asking specifically about decoupling risk from size, right?
That's right. So your A, B, and D, which, I mean, that makes sense to lead it off that way, but decoupling risk from size. So, I mean, the questions we're trying to answer is how do we get MBSE into large programs that have maybe a low risk tolerance, but are critical, as in, we can't be late. Versus, and at the same, if I may, on the flip side, smaller projects where we only have 500K. I know that's large for a lot, but
Gotcha.
and we only have 4 months, and then we're either done or not. So,
Okay, I think I understand, but correct me if I'm wrong. So I will say that the class system is specifically about risk, but most often we see, obviously, large program, low risk go hand in hand, but of course there are opportunities where that's not always true. And what I've experienced so far in my career is we decide pretty early on in the program what risk class the program is going to fall into. Like I was working a program recently where we actually went down every line item on the aerospace risks and said, okay, here we're a C, here we're a D, and we came out being a hybrid. So that might be an option, or you might even say, based on funding or the experience on our team, maybe if things were different, this would be an A, then so this is going to be a B. And based on whatever standard you decide to land on, then you could look to my framework and say, okay, we'll use these items for MBSE.
oh, so the nearest neighbor where you're closest. Okay.
Yeah, so it could be a hybrid. You could say, okay, if we're A for requirements analysis, we'll follow the MBSE guidelines for A, and then maybe we'll be B or C for verification.
Gotcha. And then your work is, given that letter, here's the guidance, try this, try that.
Exactly, yeah, because we follow this guidance for pretty much all other areas in our business, but there hasn't been something for MBSE. So I said, okay,
Oh, okay. Very interesting work. Thank you.
cool. Thanks for the question.
So I'm gonna inject a question here in between. So Dr. Dory, I did a search, a ChatGPT search on myself, and I found out I had an advanced mathematical degree from Texas Tech University, which I didn't know about. I mean, I've done that, So that's what you were referring to, the problem we've got here, and how we get assurance that this is logical, right?
Right.
So you didn't get a chance to cover that much in depth, I know, but the idea here is you're going to tie the large language models and have them represented in graphs so you can find these kinds of things.
The idea is take the text-based knowledge that is available mostly freely on the web, which includes technical documents, requirements documents, scientific papers, international standards, and using the trained large language model to convert them into models, into conceptual models in OPM in my case, so that the model can be used for implementation, for explainability, interpretability, which is lacking in LLMs as they are today.
It's gonna be interesting to watch this happen. Who's next? Go ahead, introduce yourself, please.
Good morning, Lori Zipes, US Navy NAVSEA. My question is for Nicole. It's actually a question, depending on the answer, perhaps a comment. As you were giving your whole presentation about transforming to digital, my mindset was organizational perspective. kind of my default. And then towards the very end of your presentation, you talked about talking to programs to collect information from programs, very different and from my perspective, especially when you're looking at archetypes. I think the archetypes for programs would be very different from the archetypes for organizations. So is it one or the other? Is it maybe both? Is it?
Yeah, great question. So I think we have to start with the bigger context of organizations, but to be perfectly honest, from a data collection perspective, I think we have a better shot at getting the program data. And then if we can get some traction there, maybe we can extrapolate up. But I think we're starting with programs because I think it's where we have a shot of actually being able to do it.
Right. So I don't disagree with you, but possible counterpoint.
Sure.
People who are in charge of trying to move an organization might have more time and interest in talking to you than the programs, which leads me to the one comment feedback I wanted to give you. You had a slide with challenges, and I didn't see one of the ones that I feel the most pain of, which is the analogy is we're trying to renovate the house while we're living in it. And so everyone is so busy just doing the day-to-day and getting things done on time and in cost that when I come and ask them, please change the way you do it, there's a really stiff arm at my face. And so that is reflected in there. And
It's interesting you say that, and that really resonates. And I'm hearing.
yeah, I knew you knew that, right? But I didn't see it on your slide.
I actually put that together based on doing a search of literature and people's blogs and all kinds of stuff, but I was trying to pull out the things that I was seeing as common themes, and that one didn't come up. And I wonder if it's because we're living in the space, so it doesn't even occur to us to call that one out. But I will add that. Thank you.
Thank you.
Thank you. Let's inject one more. I was curious about, I noticed that the tools database that's out there, the system engineering tools database, you guys are all aware of the system engineering tools database that's been growing. I think we're at 450 something like that. Is it in your intent to have 450 different kinds of tools available in there?
I don't think that there'll be that many people that would be willing to donate, but I think that would be fantastic, right? The more tools that we have, the more access that we have, I think the better. I think realistically, we'd probably be happy with 20 tools, right? But just for people to have access for a broader set of tools than what they're currently exposed to in their organization, I think will be beneficial. But the fundamental thing is we want INCOSE working groups to have access to tools for their work. And that's really, I know there's been different thoughts about doing an SE lab historically, but the impetus for this and the emergency here was we're trying to do the services integration model, and we were working in Mike Bernarsik's UD Mercy tools instead of having an INCOSE resource.
We're just selfish, right? You want to add something?
I just do want to add something. I just hope that as we go through this process, that we start seeing little labs of tool integrations, not just tools, because that's what's really going to be useful to us in the future.
Thank you, Tom.
Yeah, and that's definitely something that people have talked about, that the next phase, they really want it to move to tool integration. So if INCOSE has provided an integration space, infrastructure to be able to plug and play tools, but the scope for the current project is just to get people access to singular tools.
Very good. Thank you. Next question.
Yeah, Ollie DeBeck, MIT. Question for all of you. How do we teach MBSE to particularly undergraduates in, say, aerospace engineering, but could be in, any engineering field, not as an add-on to the existing curriculum? So we have a digital education committee right now. We're trying to reform our curriculum and teach MBSE as a natural part of the education already in freshman year, sophomore year, with the theory as well in an integrated way. And we're really struggling with how to do that so we don't get the autoimmune reaction from the pure theorists who just want to teach like they did 30 years ago, writing equations on the blackboard. Any advice, please?
Thank you. I totally agree that MBSE should not be taught as an add-on. And we actually at the Technion Israel Institute of Technology for the last 6-7 years have been teaching MBSE. The course is called Systems Engineering with Model, something along that line. And it is a combination of it's a hybrid combination of online course, which was produced on edX, with a project-based course that students model a system of the choosing, and it is an actual project, and it turned out the feedback is excellent, and it is doing very well. So We don't say, okay, and yes, there is, by the way, there is something called MBSE and you should use it. No, we use it right from day one as the working tool.
Grab a mic. Or step up, there you go. Go ahead.
So my undergraduate background is in physics, not in engineering. And I think there was a talk this week, unfortunately I couldn't get to it, about the term engineering in systems engineering. And this is the concern that I have and I feel is very relevant. MBSE, if it is to be taught in a supplementary case to an undergraduate study, it needs to encompass more than just the standard engineering cohorts. So I look at, my peers who are studying biology, peers who are studying mathematics, peers who are studying computational science. Just because MBSE is written and systems engineering is denoted as an engineering topic, there is some misinterpretation on its usage. And actually all of these academic fields are very useful for the community. And I feel that is an area where we are missing today. Maybe for the panel as well, I don't know what your opinions are on that too.
So in 12 years of teaching the Master's of System Engineering at Georgia Tech, we never taught them model-based system engineering, but we never taught them system engineering without digital tools in their hands, doing model-based stuff. And so, I'll just add to that, our friend Phil Zimmerman kind of famously said, we don't call it model-based mechanical engineering anymore, do we? It just is, right? So I think, the sooner that sort of the MB can go away, the easier it is for us to do this stuff.
Thank you. Oh,
Real quick,
Go ahead.
I'll just add that I've been on a panel at George Mason recently where we talked about the digital transformation and how do you infuse it into the education cross-disciplinary, as this gentleman said, not just in systems engineering. And one of the things that we kind of talked about was the notion of having real world projects that you partner with organizations or other institutions or across departments, computer science and mechanical engineering and physics and systems engineering working together on a project where you have this cross-disciplinary use and thought about models to communicate amongst those.
thank you.
You wanna add something?
Sorry, it just triggered in my head to add to that final point. We don't get an industry to that level of integration with academia until they're doing a PhD thesis. And that is a huge mistake because we envision that we take a graduate cohort in to industry and they require so much integration into actually how industry works from academia. So this, I think, this bridging of the gap. I mean, I did an internship as part of my undergraduate. It was the best thing I could have done. Not necessarily just this, but as part of your academic studies, you need to have an integrated framework of this is a project done with industry that's delivering minimal value potentially, but is something that gets people to understand the way in which industry is constructing the products of the future. Sorry, thank you.
If I could add one more point, I just wanted to bring up the idea of SE technicians. I know we've had presentation on that here, but the idea that people have to do a 4-year degree and then, as part of that, they're getting their MBSE training. The idea of having SE technicians where there's a 2-year associate's degree, they get some type of MBSE training, tool training, and then they later on get their 4-year degree. That's something I think we need to be open to also.
Yesterday, I found out I ruffled some feathers in the academic community by telling everybody, I'm talking everyone, not just universities, that we suck on model-based systems engineering. And several have come up to me and tried to explain about that. And so we've been having some really interesting, just the fact that these universities are represented here at this conference, a lot of universities are represented, is an important first step in the right direction, a good step in the right direction, right? So anybody want else to add to that question? It's a tough one, by the way. It's the same problem that you guys are experiencing to do, you guys. Same kind of problem in the universities. So, okay, let's go on.
Oh,
Next
I'll
que-
add just a little
Go ahead.
bit.
Go ahead.
So I'll go out on a limb and say I'm probably one of the younger people in the room, but yeah. Well, I want to echo what Tom said of, we don't call it model-based mechanical engineering. I never saw anything designed in PowerPoint until I got to industry. which is funny because, you know, me and my friends were joking during undergrad, like, oh, like, why are they telling us to do math on paper? Nobody's doing that in industry. And then we get there and we're like, oh my God, they are. So just make it so inherently natural that you should be doing everything digitally from the get-go. Like my first physics class before I was even in engineering classes, we were doing simulated orbital models. Like it should just be there from the very start. And our students are ready for it. I mean, I'm 25. I don't remember a time without the internet. So I am ready to do digital, and I can guarantee the people younger than me are even more prepared.
Thank you so much. Next question, please.
I come from Boeing. So this question is for Reagan, for your talk.
Okay,
And,
sir.
Speak up a little, please.
You
okay,
need to speak up.
right. So the question is your proposed solution for a specific product, or is it more addressing the generic needs for other products? Because it seems to me that it's not fitting with the paradigm of a large product or a commercial product, for example, a commercial airplane, for example. It's way more than what is being discussed in this slide. And so I just want to understand if that proposal is towards a specific, say, military product or small product, or is it targeting a generic situation?
Let's just make sure I understand the question. You're asking if it's for a specific product or type of products versus just a broad.
Yeah.
Okay, so that's actually something that I'm hoping to expand on. So if you have aviation experience, maybe you can help with that. So I know and love satellites and spacecraft. So that's what I know. And that's what I built the standard around because I see a need for that in my industry. But one of my parting goals was to actually be able to interact with people at this conference from other industries and hear about how can I make this useful to them as well. So if you want to talk afterwards, feel free to come grab me.
Okay, sure.
Thank you.
Thank you.
Next question.
So Ryan Iguchi, Aerospace. So as soon as I saw Reagan's talk on the agenda, I reached out to her. We're definitely interested in that collaboration. But one of the things that we see a lot is new programs struggling to figure out how to get started with MBSE, especially the smaller ones. And I at Kaylin Simpson's talk this morning, I inquired about, well, from a VSE perspective, very small entities perspective, it seems like there should be some guidance that we could provide them to enable them to really get started enrolling, other than go on the Wiley site and look at the 300 papers on the subject and figure it out yourself. So I think there's a lot of potential overlap with the Archetypes project, that we could start to coalesce around a small set of these program architects across multiple domains, looking at risk and maybe some other factors, and coming up with some guidance as an INCOSE product that could be helpful for commercial, government, all kinds of entities. Has there been any thought or discussion about something like that as an INCOSE product potentially in the future, and which working group would be responsible for something like that?
So we haven't talked about it as an INCOSE effort. Right now it's been within the CERC, but I would very much welcome help and support on that. And I know it would go through tech ops, but I have no idea. Would it be the MBSE working group, or where would that live?
The
Mark?
initiative is called MBSE Initiative. There's lots of working groups that
Yeah.
are going on around doing various topics.
Yeah.
So I had a conversation with, you knew there's some lawyers here. Did you know that? System engineering. They came to a system engineering conference and they wanted to think about how they could apply system engineering methods, tools, techniques to creating new laws. Because apparently there's a lot of laws being created without considering the implications of them, et cetera, et cetera.
Oh,
And
really?
so it struck me as a really good application for systems engineering, right? And so they started a working group. They're starting a working group on the science of laws. So that's what they're trying to do. You feel free to start with it. We're glad to support it.
Sure, I'll think about it, but I think there's definitely an area that's
Yeah,
transdisciplinary across multiple existing working groups. So maybe a new one is the right answer.
absolutely.
Okay.
Anybody else want to add to that?
Well, I just would want to echo what Nicole was saying. We went through over a year of SE modernization project, and we talked to a bunch of people. We hold 4 workshops, 2 of them in cozy workshops to gather information. And so we did this process and we got very little information. So, I hope we're getting more successful, but maybe if it's an cozy thing, but we've got to be open about the details of what we're doing with this in the community. And we've got to learn to share that because it's not happening right now.
I agree. And I think we're in danger of just really geeking out the two of us right now, but going to your Archetypes presentation today, I was even thinking like, so much of this is the qualities of what makes a good modeler. And while I agree with them, I also think in my head, like, some of these programs that are so new and don't have these abilities yet, like, how do you just get started? Like, it is kind of a scary thing to say, like, this is such a vastly important piece of information and I could mess it up and I don't want that to be on me. So I think there's a lot of opportunities to collaborate here, and I agree that should be something in cozy wide, not, our industry wide or my company or your company.
The line is exhausted. That's it. There's someone coming.
Just to add to that,
Go ahead.
if you want to get involved in the working groups and to learn more, come to the IW.
If you want to get involved. Introduce yourself, please.
Victoria Patterson, systems engineer, Northrop. I just wanted to say thank you for all your guys' talks. I feel very energetic right now. Two ideas kind of came to my mind when everyone went up and asked their questions, was like this kind of open forum idea where it's very structured in a way of we're conversing, but in the same time free and loose and able to kind of touch on the different architects. Like, I like the idea that it's open, shared, online. Really enjoyed that presentation. And then just the different approaches of it's almost like I wished you guys were at the systems thinking roundtable sometimes in the morning and proposing these questions. Cause then it's like, that's like a good forum to have these kind of discussions. But yeah, I understand you gotta be careful in that across different domains and things, but I love the questions that you guys proposed. And thank you so much for your guys' talks.
Thank you.
Any other questions? So we're right at the top of the hour. Couldn't have been much better time. I'm sure is there any other comments anybody on the panel wants to make before we break for lunch or whatever it's going to do?
We're actually going right into the plenary, so do
Going right to the
scoot over.
conference. Sorry. That's right. That's right. Hopefully you've seen that this is an interesting presentation mechanism. We get a lot of information across very quickly. We have a variety of topics here. And this is just a small chunk of everything that's going on, and it's accelerating faster than we can keep up with. So with that, I guess, Troy, anything you want to add? Just talk loud and grab a mic.
Just if you have ideas, things you think we should be working on next, let us know. We've talked about challenge teams, emerging working groups. Those things have come up. We want to get those things started, right? Also, Mark and I have already started talking about the IW in January. What are those themes going to be for the next set of talks? If there's a need or something you think is really important, let us know. We'll look what we can get that incorporated. And we're always trying to challenge things, right? I think all of us feel like we could be doing a lot more in this space than we really are right now. That's been one of the things that I've heard a lot of. And I think that we can get there. We just need to collaborate more and get some of these things up in front of folks. So.
Okay. That's about it. Then let's come around to the panelists.